Hello again, Matadors. Yesterday we ended with collecting some evidence about how do the mediums through which light and sound waves travel compare. And now we're moving on to how does light move from a source and going to your eye. Light is a type of electromagnetic wave and can move through a vacuum or a medium. That's how it's different from mechanical waves, is that light can actually travel through vacuum, such as space. Does light behave similarly to a water wave or a sound wave? How does it get from one point to the other? Let's find out. All right, so for this lab, there's a couple things you're going to need. First thing you're going to need is a flashlight. So you might want to go and get a flashlight. Okay, make sure it's working. Okay. And then the next thing you're going to need is a fine-tooth comb. Okay, it can be like this, or it can be one big one, whichever you like. So you need that as well. So a flashlight, comb, and then it says a solid block. So all I went and got just a shoebox. So something that's solid that you can't really see through. Any sort of a box is fine. Okay, so some sort of a box. So if you want to hit pause before we move on to this, and go make sure you have these supplies before we move on. All right, so the first thing you want to do, and I'm going to do these three things listed in your lab book, but I'm going to show you in just a moment. And what you see as we go through each of these, you're going to actually draw them on the next page. So for number 2, you're going to draw it on letter A on the next page. So if you look over here, you can see letter A. And then number 3, you're going to draw it for letter B, right here. And then for number 4, down here at the bottom, you're going to draw that for letter C. Whatever you see, whatever you observe, you're going to be drawing a model of that in A, B, and C as we go through here. Okay, so the first one, it says, is to just get your flashlight here, and you just want to turn it on and shine it down onto a surface, any surface. So here I am taking my flashlight and I'm just shining it down on my surface. And if you want to, you can draw a picture just like this showing my flashlight and how I'm just shining it down onto a surface. And describe the direction the light is traveling. Which direction is the light traveling? Is the light traveling back up at you? Well, kind of, because you're able to see it, but we're not there yet. Which way is the light traveling from this flashlight as you hold it up? It's going down, right? It's going from the source down onto the page. The next one that you want to do is you want to place a solid block a little bit of ways, and I'm going to move this out of the way so here's my shoebox here. Zoom out a little bit so you can see my cool shoebox. And I am going to place my flashlight right here about 2 or 3 centimeters away, and I want you to tell me what's happening. What's happening when the light hits the block? Is it going through? Is it bouncing back? Okay, maybe a different angle, Is it bouncing off over here maybe? Maybe a little bit, I don't know. What's happening? What's happening as that light hits that block? And you just want to write down your observations. So that is number 3, or letter B. Finally, for letter C, we're going to take our fine-tooth comb here, and I'm going to use this so you can see what's happening here as we shine the light through the comb. Wow. Okay, it says place a fine-tooth comb about 2 to 3 centimeters away from the flashlight and describe the direction the light is traveling as it moves through the openings of the comb. Wow, where's it traveling? And go up like here so you can see that. Wow, it's crazy. Is it going through the openings there? Okay, if I go like this, what happens there? All right. Those are the lab. You can do this at home with your own supplies, or you can just follow along with mine. And we're going to go back over here Hopefully you were able to, let me go ahead and zoom back in here. Go ahead and draw a picture of the models you just saw for A, B, and C from the previous page. And let's move on to light sources. To see an object, there must be a source of light. An object that produces light is often described as emitting light. So examples of light sources are, of course, the sun, traffic lights, a firefly, and of course for yours, it was the flashlight. That was our source. Light travels as waves moving away from a source. Scientists often describe these waves as countless numbers of light waves just spreading out in all directions from a source. Notice I've highlighted these because I believe that they are very important. In the figure on the right, you can see shadows made by the tree trunks. The spaces between the rays are shadows or places with less light. The shadows show that light normally travels in a straight line. However, objects in the path of that light ray can cause the light ray to change direction. Light can also spread out slightly as it moves through a small opening like you saw with the combs. Okay, a couple more things for this video is we've got a 3D model here. So, explain how you know that light travels in a straight line. How do you know light travels in a straight line and does not curve around objects like we saw with our sound waves? Once they went through an opening, it kind of curved around that opening when we were looking at sound waves. So use this lab that we just did with the flashlight and the comb. How do you know that light travels in a straight line? Give me some evidence from what we just saw. Our last thing today is we're going to go back to our CER and collect some evidence in evidence C, so on page 69. So I'm going to flip back over to my CER here on page 69. And here we have it right here. So what evidence have you discovered to compare how light and mechanical waves move away from a source? Well, hopefully you were able to see that both light and mechanical waves, such as sound or water waves, can be rays that move. How do they move from the source? How do they move? Which direction? And that's all you need to do for this video. Let's move on to part B. In the next video, we're going to continue with our next lab. So make sure you have these supplies with you. There's quite a bit of them. So here we have flashlight, beaker. If you don't have a beaker, you can get just a glass, mirror, a note card. I just got cardstock paper, so just like cardstock paper, make sure you can punch a hole in it. A thermometer, that one's going to be a little bit more difficult since we all have digital thermometers. Get some water, get an empty milk jug. I used a water jug too, and then of course a hole punch. All right, when you get those, we'll see you back here for part 2 of this video.